Electric vehicles, or EVs, are often praised as the future of eco-friendly transportation, but there's a side to them that needs more attention. While they offer a greener alternative to traditional cars, they also introduce certain safety concerns that can't be ignored. It's crucial to discuss these issues, especially as the adoption of EVs continues to rise. Let's break down 6 key risks that electric vehicles pose on our roads. Number 6. Fire hazards. The lithium-ion battery concern. While EVs promise a cleaner and greener future, their lithium-ion batteries can pose serious fire risks. These batteries are the heart of electric vehicles, but they are also susceptible to a phenomenon called thermal runaway. This is when a battery overheats and catches fire, potentially leading to explosions. For example, in early 2024, a major fire broke out in a San Francisco parking garage due to an EV battery. The blaze spread rapidly, causing significant damage and raising concerns about the dangers associated with EV battery fires. To put this into perspective, data from the U.S. National Transportation Safety Board shows that there are approximately 25 fires per 100,000 EVs sold. In contrast, gasoline-powered vehicles see about 1,530 fires per 100,000 vehicles. While EVs are far safer in terms of fire incidents compared to traditional cars, the fires that do occur can be more difficult to extinguish. Emergency responders require specialized training and equipment to handle these fires safely, making emergency situations more complex. Manufacturers are actively working on improving battery safety, but until more advanced technology is available, the risk of fire remains. The push for greener transportation should not come at the cost of compromising safety. Number 5. Emergency response complications. As EVs become more common, emergency responders are facing new challenges. EVs require different protocols and specialized equipment to safely manage accidents. Traditional rescue techniques don't always apply to these vehicles due to their unique design and technology. The high-voltage battery systems in EVs present a serious risk to responders, as improper handling can result in electrocution or further complications. Despite efforts by organizations like the National Fire Protection Association, or NFPA, to train responders, many emergency teams still lack the necessary tools and knowledge. A 2024 incident in Los Angeles highlighted how much longer it took to rescue occupants from a crashed EV compared to a gasoline-powered vehicle. In addition, EVs often have reinforced battery compartments that complicate rescue operations, making it harder to access victims. Furthermore, the specialized firefighting techniques required to manage lithium-ion battery fires demand more resources and can lead to environmental concerns. Emergency protocols need to evolve alongside EV technology to ensure that safety isn't compromised during a crisis. Number 4. The weight issue. EVs as heavier vehicles. Another significant concern with EVs is their weight. These vehicles are often much heavier than their gasoline counterparts, primarily due to the large batteries they carry. For example, the 2024 Ford F-150 Lightning Platinum weighs about 6,893 pounds, 42% heavier than the gasoline-powered F-150. The 2024 GMC Hummer EV is even heavier, tipping the scales at around 9,063 pounds, with its battery alone weighing almost 3,000 pounds. This increased weight creates a higher risk in crashes. Studies show that adding roughly 450 kilograms, or about 992 pounds, to a vehicle can increase the likelihood of a fatal crash by 40%. The added mass makes these vehicles more difficult to control and stop, especially during emergency situations. Additionally, the rapid acceleration capabilities of EVs mean that their braking distances are longer, further complicating accident scenarios. The weight of EVs is not just a design challenge, it also raises serious safety concerns for both passengers and other road users. Manufacturers need to find a balance between performance and safety, ensuring that the weight of the vehicle does not compromise its crashworthiness. Number 3. Flawed safety features. While many people assume that EVs are safer due to their high-tech features, this is not always the case. One of the major concerns is the crumple zones in EVs, which are designed to absorb the energy of a crash and protect the occupants. However, the extra weight of EVs can overwhelm these crumple zones, making them less effective in certain types of accidents. The heavier the vehicle, the more kinetic energy it carries, and the harder it is for the crumple zones to absorb that energy, increasing the risk of severe injuries. Another issue is the reliance on automated driving systems, such as Tesla's autopilot, which is marketed as a means of enhancing road safety. However, these systems are still considered to be in the early stages of development. Tesla's autopilot, for instance, has been involved in a number of high-profile crashes, raising concerns about the readiness of this technology for real-world driving conditions. The over-reliance on automation, combined with the inability of crumple zones to handle the added weight, can lead to catastrophic outcomes in certain accidents. While EVs are often seen as cutting-edge, their safety features must be refined to ensure they are fully capable of protecting passengers in real-world crash scenarios. Number 2. Advanced Driver Assistance Systems, or ADAS. ADAS technologies like lane departure warnings, adaptive cruise control, and automatic emergency braking are marketed as safety features that help prevent accidents by maintaining safe distances, assisting with steering and applying brakes automatically when necessary. While these systems can help reduce human error, their effectiveness with heavier EVs is still a subject of debate. Due to the increased weight of EVs, these vehicles require longer stopping distances. The added mass means that EVs generate more kinetic energy, which takes more time to dissipate, making it harder to stop quickly in emergency situations. Furthermore, ADAS systems rely on sensors and algorithms which can sometimes fail or misinterpret the environment, especially in challenging conditions such as heavy fog, rain, or glare from the sun. This makes ADAS features less reliable than people might think, leading to potential safety risks when they fail to perform as expected. There's also the issue of driver complacency. As EVs become more reliant on these systems, drivers may become less engaged, assuming the car will handle everything for them. This complacency can be dangerous, particularly if the ADAS system fails to recognize a critical hazard. While these systems are improving, they are not foolproof, and it's important for drivers to remain alert and aware of their surroundings at all times. One of the most concerning safety issues with EVs is their near-silent operation at low speeds, which poses a danger to pedestrians and cyclists. Traditional vehicles make noise when moving, allowing pedestrians, especially those with visual impairments, to detect their presence. However, EVs are much quieter, and this makes it harder for vulnerable road users to hear them coming, increasing the risk of accidents. Studies have shown a 20% increase in pedestrian and cyclist fatalities involving EVs compared to traditional vehicles, which has led to calls for stricter safety regulations. In response, regulations now require that EVs emit artificial noise at low speeds to help alert pedestrians and cyclists. Unfortunately, not all EV manufacturers comply with these requirements, and not all models feature this safety enhancement. To mitigate these risks, manufacturers need to prioritize safety features like advanced sensors, automatic braking, and better pedestrian detection systems. Public education campaigns are also essential to raise awareness about the unique risks posed by quiet EVs. Looking ahead to the anticipated ban on combustion engines by 2035, the adoption of electric vehicles will only continue to grow. However, this presents new challenges in terms of safety. The added weight of EVs means that crashes will carry more kinetic energy, potentially turning minor collisions into major accidents. Manufacturers must adapt by developing tailored safety features for EVs, recalibrating crash tests to account for their unique characteristics. From better battery protection to more sophisticated ADAS technologies, innovation will be key to ensuring that EVs are not only environmentally friendly, but also safe for everyone on the road. If you found this information helpful, don't forget to subscribe to the channel for the latest updates on vehicle